In this question, a truck is dumping gravel into the shape of a cone. We are being asked about the change in the height and radius of the cone, and in part A, we are being asked at how fast is the height of the conic pile changing when the height is 7.7 feet tall, and in part B, we are asked at the rate at which the radius of the pile is changing when the height is 7.7 feet and the radius is 11.55 feet. In the question, we are given that the diameter is 3 times the height of the conic pile. This has been modeled with our equation d equals 3h. We already know from previous knowledge that the radius is half of the diameter. So we know that the radius is the height of the conic pile times 3/2. In the question, we are also given the rate at which the volume of the conic pile is increasing, which is 19.5 feet cubed per minute. The formula for the volume of a cone is V equals 1/3 pi r squared h. In this question, in order for us to figure out the rate at which the height of the conic pile is increasing at 7.7 feet, we must substitute in 3/2 times h for the radius in order to have a solvable equation. When we substitute 3/2 times the height of the conic pile into the volume equation, we get V equals 1/3 pi times 9/4 h to the third. We got this answer because 3/2 squared is 9/4, and h squared times h is h to the third. If we combine like terms, we get V equals 3/4 pi times h to the third. Then we can derive. The derivative of that is dv over dt equals 9/4 pi h squared times dh over dt. We are solving for the derivative in respect to dt. So we have dv over dt as well as dh over dt. Now we substitute in our measurements. For dv over dt, we have 19.5 feet cubed per minute, and for the height, we have 7.7 feet. The reason why we substitute in 7.7 feet in for the height is because the height is not a constant in this question. The height is ever changing, which is why we substitute it in after we derive. Then we solve. We square 7.7, multiply it by 9/4 and pi, and then divide all of that by 19.5, and we get 0.047 as the rate at which the height of the conic pile is changing when the height is 7.7 feet. So, the answer to part A of the conic pile question is the height of the conic pile is increasing at a rate of 0.047 feet per minute when the height is 7.7 feet. We do use some aspects of part A in part B. Part B, we are being asked about the rate at which the radius of the conic pile is increasing. If we look back up here, we remember that the diameter of the conic pile is 3 times the height, which means the radius is 3/2 times the height of the conic pile. Because we are solving for the rate at which the radius is changing, we need to make sure all of our terms in the volume equation are similar and we have a solvable equation. We do this by substituting in for h 2/3r. Because we figured out in the previous problem that r equals 3 times the height divided by 2, we can then solve for h by multiplying r by the reciprocal, 2/3 times r. Now we just need to figure out the radius. In the problem above, we were given that 3 times the height is the diameter, and we know that 3/2 times h is the radius. Because we were asked to find the radius when the height equals 7.7 feet, we can substitute 7.7 feet into our radius equation, 3/2 times h. When we multiply 3 times 7.7, we get 23.1, and when we divide that by 2, we get 11.55. So the radius of the conic pile when the height is 7.7 feet is 11.55 feet. Now, all we need to do is substitute the appropriate terms into the equation, derive, and solve. When we substitute in for h 2/3 times r, we get 1/3 times pi times r squared times 2/3r equals v. When we combine like terms, we get v equals 2/9 times r to the third. When we derive with respect to t, we get dv/dt equals 2/3 pi r squared times dr/dt. Now we substitute in 19.5, which was given to us as the rate at which the volume of the conic pile is changing, and we also substitute in the 11.55, which is the radius when the height is 7.7 feet. When we substitute that into the derivative, we get 19.5 equals 2/3 pi times 11.55 squared times dr/dt. When we square 11.55, multiply that by 2/3 and pi, and divide all of that by 19.5, we get dr/dt equals 0.0697, or when that's rounded, 0.070. Now we have our answer for part B, which is the rate at which the radius of the pile is changing is 0.070 feet per minute when the radius is 11.55 feet and the height is 7.7 feet.